and batteries look like. This panel is presented by RMIT and the Integrated Climate Action Clean Energy and Circular Economy platform, known as ACEC22, which is also a part of RMIT. My name is Caitlin Phillips-Peddlesden. I'm the Circular Delivery Lead with RMI Activator, and I also work on the Victorian Circular Activator, which is a collaborative partnership looking to support Victoria's circular transition. Before we get started, I would like to acknowledge the Gadigal people of the Eora Nation as the traditional owners of the land on which we're meeting here in the room, and encourage those online to pause and take a few seconds to acknowledge the traditional owners of the lands that they are meeting with us on. And I also like to pay all of my respects to elders past and present. And I also note that all of the lands in Australia were never ceded. So we're meeting in hybrid format today. So welcome to everyone online and to those in the room. As I said, we have a moderator, Mohana, online with any issues. So just pop your problem in the chat or any questions and Mohana will help you out. And we'll also do our best to make sure that online is also included in today's proceedings. So we're following a pretty traditional format. We'll have some presentations from our
Tasbirul.
If you could all just mute when you're online, that would be fantastic. And noting that we've got 2 panel members in the room with us here and also 2 members online. So could make everyone welcome. Those of you who are online, we will have a question and answer session at the end and also for those in the room. So if you could pop your question in the chat if you're joining us online, and for those in the room, we'll have some mics coming around if you have any questions at the end. So to set the scene for today's discussion, and before I introduce us to our panel, I'd like to note that we can see a movement building around the rise in alternative energy and storage solutions. This is supporting the the imperative that we see for renewable energy transition, but this also comes with a rise in quote unquote waste materials, and therefore a growing need to manage this waste and ideally design alternative solutions. So our 4 panelists today are going to outline their solutions that go beyond simply managing this waste and instead looking at a circular economy approach, where they're researching solutions that will focus on 2 key products and materials. So solar panels, also called PV or photovoltaic in the session, and lithium batteries. So just a little disclaimer, I'm not a researcher, nor am I in the tech or the STEM field, so I don't know a lot about this stuff, but I think it's really interesting. So I'll be helping us kind of ask questions and, get all of the juicy detail out of our panelists today. And also noting that following the communique a couple of weeks ago that the Australian government's intention to develop a regular product stewardship scheme for solar panels and household electronics. So I think it's a really kind of pertinent time that we're having this discussion today. So now to our panel. With us today, we have 4 amazing researchers in the field. In the interest of time, I'll introduce each of them as we come to their presentation, and then they'll have some time to tell us a bit more about their research. So first off, we have Dr. Tasbirul Islam, who's joining us online. So Dr. Islam completed his PhD in engineering from Macquarie University in 2020 with research titled Achieving a Circular Economy for the E-Waste Sector in Australia. His H-index is 16 with 33 research documents, and as a research fellow at IC3P, he's now currently working on various projects associated with circular business models. So Tasbirul, if you could share a little bit more about your research.
Hi, Caitlin, thank you very much. I am Tasbirul Islam. I was researching about electronics waste, where I come across the issue and the importance of circular economy. And so broadly, solar PV panel and lithium-ion batteries that connects with the broader e-waste sector. So I was trying to understand what are the things that needs to be connected with the circular economy and e-waste. So during my PhD, I took an approach to understand the potential material recovery from the e-waste stream. So in that case, I developed several mathematical models, to understand the future potential of the materials inside of this waste stream. And at the same time, I try to categorize the e-waste under the regulated and unregulated waste stream. So lately, solar PV has been considered as a priority waste streams, and as well as e-waste, which is a very good thing for the further progression in this area. So beside that, I also involved with consumer behavior related aspects, trying to understand like what are the mm, socioeconomic issues that are associated with consumption and the disposal behavior of consumers related to e-waste. So at RMIT at this moment, I'm currently doing research on circular business models. So in that case, which is sometimes a very complex issue, like connecting many of the actors and collaborators and industry partners. And if you take a look at the waste stream, it connects many of the actors across the whole supply chain. So at this moment, I'm researching to develop the CBM adoption frameworks and try to engage with the business and stakeholders to understand the resource potential of various different waste streams. And at the same time, I developed a database of the international best practice case studies related to that, so that we can apply those experiences in the Australian context. At the same time, I was involved with the circular business model canvas kind of tools that is very essential for the businesses to understand the opportunities. And third stream of my research is currently understanding the product lifecycle management and develop a decision support framework based on the material flow analysis and lifecycle assessment. I'm also involved in understanding the opportunities and barriers associated with the circular business model, specifically from the manufacturing sector. As we can see from the, in order to understand or identify the potential opportunities, we need to understand the leakage and as well as the inefficiencies in the across the whole supply chain. So these are all of the aspects that motivated me to apply the circular business model in various different streams, and solar PV and EV batteries are one of the main kind of things. Yeah, thank you.
Thanks very much, Tasbirul. Next, we have Alston Furtado. Alston is an engineer by training, and he completed his master's by coursework in engineering management. He has around 2 years of experience in the battery and solar energy recycling retail sector, and currently he's pursuing his master's by research in circular business models for end-of-life electric vehicle lithium batteries in Australia. Thanks, Alston.
Thanks, Caitlin. As Caitlin mentioned, my name is Alston Furtado and currently researching on end-of-life EV lithium batteries in Australia under the supervision of Professor Usha Ayaraniga and Dr. Razul Schumann. This project, which I'm undertaking, is also part of IC3P, which stands for Integrated Circular Economy, Clean Energy and Climate Resilience Platform. Next slide. Thank you. So as you can see, under the linear economy, after battery material extraction, typically the batteries, they undergo manufacturing, installation in EVs, the application, and finally at end of life, it's disposed of to landfill. But under the circular economy, and depending on the type of loop that you choose, that is either slowing or closing loop, you can reuse the battery in less intensive vehicles like forklifts, for example. You can repurpose the batteries into a secondary application such as energy storage. You can remanufacture or repair those batteries, and finally recycle those batteries. So the image you see in the bottom right over here is an example that I've taken from Nissan. Currently in Japan, what's been happening is, just to give you an example, is batteries at end of life. After they reach end of life, they are graded according to their state of charge, and accordingly, they go into either reuse, refabricate, or repurpose and recycle. One of the examples I would like to share is the end-of-life EV batteries have been used in the Johan Cruyff Stadium in Amsterdam. And now typically where we are in Australia, we are actually much further behind as compared to the European, our European neighbors and even Japan and parts of the US. And mainly this is because of the volume, the lack of incentives and the lack of research in this sector, which is why my objective in my research is to identify the key factors required to develop a circular business model, especially for these end-of-life EV batteries in Australia. I started my research earlier this year, and right now I'm in the interview phase and data collection phase. So I'm due to complete my thesis late 2023 or early 2024. And I've also, in the previous slide, you can see my email and LinkedIn. So if you have any questions, please feel free to reach me after this session. Thank you.
And just to note, we will be sending around contact details if anyone would like to reach out to any specific researcher following the panel. Thank you, Alston. It's interesting to see opportunities for sort of those higher order R types before we get to recycling with this type of material, which is exciting to see. So next we have Alejandra Nunez Madrigal. Alex is an industrial designer by training. And now a master's research candidate in applied sciences in the built environment, whose study focus is on photovoltaic waste management in Australia, using circular economy strategies, embracing knowledge from overseas best practice examples and adapting them to the Australian context. And just to note that Alex is experiencing some kind of hay fever type reaction to both the pollen and the aircon in this room. So if she's coughing a little bit, that's why.
Hi, Catherine. Thank you. As I mentioned, I'm having a little bit of problem, so I'm going to try to say the most of the importance in few words. So I have been 1 year into research of what is there to do with solar panel waste, because solar panels waste is toxic and it's just increasing in the coming years. So as you can see in the next slide, we have a problem because this in Australia is going to be 10,000 tons of PV waste in 2025. So it's not far away that we need to develop some sort of strategies to deal with this. And to the point, there's nothing said yet. It's not regulatory aspects or frameworks that can deal with it. And worldwide is still young stage as well on how would be the best way on dealing with it. So on the, sorry, on this topic, then there would be two approaches that would be able to be seen from the circular economy, where we are trying to get the best of the product for the most extended time of it before it can become as waste itself. So we have two aspects in here that I wanted just to share, because one of them is being developed by Ellen MacArthur Foundation, where they are trying to focus on how these would be even shared, or the product, like the product service systems where you can share them or lease the solar panels in order to try to expand their lifetime. Or the other approach that I'm trying to adopt through my research is how to adopt the 10 R's for the circularity. So previously it was just 3: recycle, reuse, and I think it was recycle, reuse, repurpose. So now, even if you've got 10, you've got 10 more, well, 7 more options on how to deal with them. It's not just about what the technical end would be, it's on how you can make the best while it's being still efficient. Because solar panels is quite difficult to try to unassemble them and then try to send them to recycle. And depending on many of the circumstances where they have been installed, is that their lifetime is not 30 years as they are supposed to be. They can be as short as 2 years. So one of the most important things about these kind of strategies is on how to recover materials from them once they have actually reached the end of life. And this recovered materials is the tricky part. So recycling is something that is still being developed in several countries. And if it would be a good way to find, if we would find a new or good appropriate way to recycle the PV panels and recover those materials, according to Irina, you could have at least, I think, $2 billion product out of the waste. So why not to do it? If we have the chance, let's make the best of it. And that's it. If you are more interested, I'm sure that we can provide you more information. Thank you.
Thank you, Alex. And now, last but not least, we have Dr. Ylias Sabri. Dr. Sabri is a chemical engineer, engineering honours by training, and completed his PhD in 2010 in applied sciences, looking at nanomaterials and sensors. Currently, he manages the Nanotechnology and Chemical Sensor Group in RMIT University, and is actively working on various patented technologies in addition to many publications. So over to you, Elias.
Thanks, Caitlin. The sound is okay? You can hear me?
Yeah, perfect.
Fantastic. So yeah, as Caitlin mentioned, I'm a chemical engineer and senior lecturer in that department in RMIT. I have a chemical sensor background, but I use my nanomaterial and chemistry background in a lot of industry projects that requires this type of recycling. So we got a couple of projects on tires, biomass, and solar panels. So I will try to introduce our solar panel upcycling project. It's about 2 years in the running. This project is a CRCP $3 million project that was awarded to our lead industry partner, or OJAS Group, in the middle there. And the two research partners in here is Melbourne University and RMIT University. As you can see, LXM down the bottom, they are a spin-off company, which means it's a company that's actually building plants, 3 plants around Australia, in order to recycle solar panels as part of this project. So this has just been launched in the past few months. Next slide, please. Thanks. So if you guys are wondering what's in your solar panels, I developed this image of the whole thing going after a lot of literature and company websites. So you got your aluminium frame, you have your glass in there as a first layer, then you have a glue, which is a polymer, it's referred to as EVA, and then that glue is stuck to your photovoltaic cell, which does all the work, converting solar energy into electrical energy. Then again, you have that same glue underneath it, and that glue sticks to the back sheet, which is the sheet that's shown on the right. So that's 3 layers of polymers. So there's a PVF layer, a thin layer, then a PET layer, which is used in your drink bottles, then again another PVF layer. And the problem is this PVF layers. These PVF layers are supposed to be very inert, but what they contain is fluoride. And in America and a lot of other countries where they try to recycle solar panels, they try to burn the glue, the EVA that I showed you before, that's between the glass and the photovoltaic cell. In trying to burn that off to separate the parts out, you get this PVF also evaporating. And when fluoride evaporates, it's poisonous, and it also destroys the ozone layer as we know it. So the big challenge in solar panel recycling is to develop a process where it's environmentally safe and it's also sustainable in terms of the economics. So the industry that's doing the recycling can profit as well. So that's some of the challenges we're working through. Next slide, please. Next. Yeah, so this one is just a summary, just to give you an idea how much of everything there is in solar panels. As you can see, there's about 70% of the weight is glass, contains glass. Aluminium, which is about 20%, is very easy to come off, and we do that straight away. And the most profitable part there is probably silicon, and even more than that is silver. But silver is there at the least amount, as you can see, 0.05%. So the work that we're trying to do is develop a process to recover most of the silver, because in countries like America, recovering 15% of the silver that's in there makes the recycling very profitable. However, in here, we're trying to recover even more, because as you know, they'll be using less and less silver in the new solar panels. Next slide, please. So this is the final one. I just wanted to introduce to you what our project involves. So what we have on the left side, you got your solar panel, end of life PV panel. that goes through this machine called the Vortex. So all this is like a big plane engine or a big mixer, you can think of it. And when the solar panel goes inside here, there's high pressures that are formed inside the tube that breaks apart the solar panel. And what comes out from the other side is your glass, which our industry partner is using in concrete. So sand is very hard to access now, virgin sand. So we're trying to replace sand with glass in concrete. And the other product that comes out of this Vortex machine is our backsheet and the photovoltaic cell, which I'm showing on the top. It says laminate, no glass. So that's the part where we're trying to process now using different chemical methods, physical and chemical methods, to try to separate them into their compartments and market them into different products. I think that's it. So that's our project. Thanks.
Thank you, Elias. And a big thank you to all of the panelists for your interesting presentations. I've got a few questions for you all, and after which we'll throw to the audience, both online and in the room, for your questions. So firstly, Alex, what are the circular economy considerations in lithium batteries and photovoltaics? And why is this an important issue for research now?
As I mentioned before, both the lithium batteries and solar panels, if they just go to landfill, they have a high toxic hazard, not just for the environment, but the human health as well. So that's one of the main reasons why now, because it's just going to increase. And in Australia, solar power is just increasing year by year. So it's something that will come very fast. It's faster than what everyone was expecting. What could be the first step towards it is maybe know what it's on them and which would be the best way that the government and the industry can deal with it. Because as far as the research goes, is if there is no regulation and there's no frameworks, then the industry basically don't have the incentives to just keep on forward with it. So having the plan on what to do, how to do, and who needs to do what would be the first step, at least to have everyone on the same page and clear on the responsibilities of the materials and the life cycle of both products.
Sure. And Alston, can you explain for us what end of life means, and where does this occur for EV lithium batteries?
Thanks, Kate. So end of life for EV batteries, typically you can say that it occurs when the battery no longer meets the performance criteria of a vehicle. Now, ideally for batteries, you'd like the end of life to be between 5 to 15 years. But in terms of their charge capacity, when the capacity reaches about between 60 to 80%, that's when they are rendered, they're no longer rendered suitable for EV vehicles. That being said, you can also experience end of life much before that 5 to 15 year range. And this can occur because of any falls or unforeseen risks. Thanks.
So there's quite a few different factors there that come into it. Throwing now to you online, Tasbirul, could you describe for us what a circular business model is, and maybe give us an example, and ideally a kind of relevant one for the discussion today? You're on mute, Tasbirul. Perfect.
So circular business model is the way that how a company creates, captures, and delivers value. So with the value creation logic. So generally, if we see the trend in the linear business model, so in that case, we are trying to produce more and to get out of the profit by selling the products. But in circular business model, we try to capture or create the value in a way that it can last for the entire life cycle of the product. And in that case, we use some reuse, remanufacturing strategies, and at the end, we do the recycling stuff. So the main intention is to improve the resource efficiency and extending the useful life of products and parts. And finally, the closing the loop by doing the recycling. So in terms of like the circular business model is very diverse, as the sectors and the product specific issues are combined together. So for example, if we talk about the solar PV panel or the battery, it contains many of the plastics that we see, many of the aluminiums that we see. So in the holistic waste stream, there are many different waste that contains the plastic. So other e-waste stream is also related with the plastics, coppers, and other things. So so in general, if we want to categorize the circular business model, there are 5 distinct types of circular business models, such as circular inputs. So use of bio-based materials, renewable energy during the production process. Then there is a sharing platform where we use the product so not by ownership, but rather we use it. So if we so community batteries, so community solar farm could be a good example of sharing platform. Product as a service is another type of business model where consumer don't need to buy the solar panels or the battery that is associated with the solar PV panel, but a company can take charge of it, the whole system, and at the end of life they will be responsible for taking out of the system from your home. And there is another business model is called the product use extension, where we employ the repair kind of activities, maintenance. So in that case, it could be part of the product and service system. And at the end, we have resource recovery type of business model, where mostly we're talking about the recycling stuff. So it could be waste or the byproducts. So so broadly, this could be an overall understanding of the circular business model. Thank you.
Thank you. So it sounds like there's some, business model solutions that mean that we can, retain some of the value in some of these products and materials before we're getting to the point where we're looking at remanufacturing or repair.
Yeah,
that's great to know. One for you, Elias. Do you think kind of changes in technology and technological developments will affect the possibilities for circular design for end-of-life PVs?
Yeah, absolutely, Caitlin. That's a very nice question. Actually, people are trying to use different types of materials now in solar panels. So in the next 30 years, hopefully we'll get more of these better engineered panels being used in terms of keeping in mind the circular economy part as well and the end of life. A lot of them do use new materials just because they're more efficient. So for example, cadmium telluride selenide based materials are used as semiconductors because they're much cheaper to put on there than your silicon. You can put very thin layers on there, so you can control them into nanometer size, and they're also much more efficient. Also, those type of panels that's come to us, they have better engineering, as I said, so they don't have this PVF layers in them. Instead, they have 2 glass on the 2 sides. So it's designed quite differently. And from our perspective, maybe not the manufacturers, maybe they hadn't thought of this, but from our perspective, we are able to separate them much easier. So our industry partners very rapt about that, and they got quite a lot of them coming through from overseas for us to process. So definitely, just by using different materials, you can have much better end of life and circular economy process implemented.
Fantastic, thank you. Maybe Alex, Alston, you can sort of share this one, but currently what's being done with PV and EV lithium batteries waste from a circular perspective, and maybe focusing on Australia and maybe some international kind of comparisons?
Thank you, Kelly. I'm just going to answer for obviously the solar panels. Right now, most of solar panels are being recycled, but in Australia, only 17% of the solar panels is actually being recycled. The rest is just considered as waste, and it's either exported or illegally put into the landfill, because there's just 3 states in Australia that have the ban of the landfill for the solar panels. So that's why we need to do something now, because basically it's just resources that are being left on the landfill or just shipped away.
Thanks, Alex. If you look at what's happening overseas, there's actually quite a bit happening overseas. If you look at Japan, Nissan formed a partnership with Sumitomo Corporation to form 4R Energy. So they started on early on in 2010 when the first Nissan Leaf battery was introduced, and they actually repurposed the battery in, as I mentioned earlier, in Amsterdam. If you go in Europe, you have the partnership with BMW and Northvolt, and also Renault, who has started called as a refactory aimed at, who's going to start a big factory called as refactory based on the circular economy principles. In the US, you can also see the partnership between Tesla and Redwood Materials, who recycle the batteries. So quite a bit is happening in overseas. In Australia at the moment, the problem we're facing is there's not a lot of volume. So you won't see volume of these end-of-life batteries. So you won't see much happening here. But that being said, recently, not long ago, Nissan actually posted a news article wherein they've started a pilot study when with partnerships, forming a partnership to electrify. It's a small startup company who is working on developing an advanced control solutions for repurposed batteries. So the repurposed battery is going to power a factory down south in Melbourne, one of their casting factories. So it's happening slowly, but right now, because we are seeing the uptake of EVs, but I would say it's at this stage, not that many to see a lot in a commercial scale.
Sorry, I just want to add on that because I did miss the part of the overseas, what's being done overseas with solar panels. So mostly recycling. Germany, France, Japan, and United States are currently the ones that are leading this. There are many others that are coming into the game as well. And in the reuse part, the Netherlands has some programs to reuse, and in United States, this program of leasing solar panels as well is something that is starting to be stronger. And in Australia, there's as well research, and already there are companies that are looking on how to reuse solar panels and certifying, which is very important as well, these solar panels that are having their second life.
Thank you. I think it's really interesting, that kind of rise in product as a service sort of options, and particularly for sort of complex products. We might jump to audience questions. We've got a couple online, and we can check if there's any in the audience here. So we've got a roving mic coming, but I'll just go to one online while we're grabbing that mic. Yun says, what are the existing plans on recycling the actual silica and conductive cell material? I'm assuming that's solar panels. So yeah, so that's for Elias, I think.
Okay. Yeah, so at the moment, the challenge is to separate the silica, and I assume you mean the silver as the conductive material inside silver. We have lead and tin in there, which we're trying to separate and try to recover them, and so they don't go into the environment. In terms of silica, we've had our industry partner being approached by battery industries, so they want to see if we can use them there as a R&D here in the university, and then show them some results if it's viable for them to take it up. They're also talking with silicon manufacturers and also construction industries. So they're hoping to market it into some of them, depending on the purity that we can get it out, depending also on the process that we will develop, whether any of these materials is going to be oxidized or not. So there's quite a complexity involved in terms of what you're going to get out of the solar panel, depending on what type of process you're going to use. Our aim is to try to recover as much of the silver without oxidizing it. So we're just trialing a few different processes in that, which are IP protected. But yeah, anything else, silicon, we have to look at the purity and then market it for that particular application. We are working with some battery experts in the university to test the silica that comes out as well. Because it goes through the vortex process, you do get them shattered, of course. So we try to modify the surfaces as well for some applications.
Great, thank you. Any questions in the room here?
Yeah, I've got one. This one's for Alston. Just in terms of, and thank you all for your presentations. Very informative and insightful. Just in terms of EVs, and I'm glad you actually focused on this. They seem to be at the forefront of doing EVs. I'm not sure if I read it correctly, but Nissan Leaf, is it bi-directional? And when I say that, was there or has there been contemplation of actually using the vehicle as the energizer in the home? And so plugging the car into the home and then using the home, and what consequence would that have on the battery usage and the life? And then I suppose taking that next step further, which was talked about leasing. I think Alex, you mentioned about leasing of solar panels and taking them back. Maybe that could be in contemplation for the EVs as well. So yeah.
Yes, I can talk a little bit about that. So in what you see what's happening in Japan, when I mentioned the 4-hour energy, they actually have a project, if I'm not wrong, it's called the Blue Switch project. And what they do is, as you know, Japan is more prone to tsunamis and natural disasters. So the batteries in your Nissan Leafs, they are used to power the rural areas, any small, stores and stationary stores, acting as a mobile source of energy. Now, what happens to the batteries? On the technical answer, I wouldn't be able to answer that, but I'm pretty sure that from what I read in the report, is that before the electric vehicles, the whole idea of electric vehicles did come out, they actually anticipated all this. And that's why in 2010, that is way before electric vehicles actually became quite popular, they mentioned that, at the end of life, it'll still have that 60 to 70% of charge, and it can act as a secondary source. So even if, let's say, at the end of 7 or 5 year period, when you take out the battery, it'll still have enough charge to power that, source. And that, yes, exactly. And that reflects upon product as a service model or product life extension model, a combination of that, kind of slowing the loop. Thank you.
Great, that sounds fantastic. We have one here for Elias as well. Is there any heat treatment involved in the vortex process? And related to that, what is the material recovery rate?
Okay, no, the vortex process is actually, as I said, it's like a big mixer. So it actually takes in about 10,000 meter cubed per minute of air into it and creates around 150,000 PSI pressure. It's about 10,000 atmospheres. So it's quite a high pressure. So high pressure, but just room temperature. However, we have found that there's heat spots that gets created inside there, but we're not actually putting any heat in there. Okay, so it's all room temperature. And the processing rate for solar panels, we could do 2 per minute. I think, yeah. 2 per minute, so 30 seconds each. Yep.
Thank you. We've got one from Zephan in the chat. What are the gaps and limitations you have identified in promoting the reuse and recycle of PVs and batteries in Australia? And what is required from the local and Commonwealth governments to support this? So this could be relevant for anyone. Alex, jump in.
I think one of them is quite important is trust and obviously awareness. Most of the people who would be able to say, oh yeah, I would be interested in having a Second Life solar panel, they need to have the certification that it's not going to explode or that it's safe enough or that it's going to do or perform specific things or provide this specific energy. Because if you don't know what you're getting, then it's not as attractive idea to be actually involved with it. So one of the things that the government would do or the industry can do is just try to develop this kind of information or digital labels that will inform the users and the industry on what's in that solar panel, what happened to it, and how long it has left of life or useful life. And then if you got all this information, then you can decide how you can just bring that market up and then probably expanding it as much as possible. Because right now what can be done with solar panels, it's just things like urban lights. It's not something that will power up something big, you're gonna use it like in solar farms, but they definitely have some energy left that you can use, even in a small part like sheds or something that is not that energy, and doesn't require that much energy. So that's, I think, something that could do as well.
Yeah,
for
probably I could add
projects.
to that. Right now, I'm conducting interviews, as I said, and what I've noticed is another limitation is the lack of focus or a clear vision. Especially after conducting interviews with manufacturers and government researchers, it's very easy. What I've understood is very easy at the end of life to dispose of the battery to a recycler, because then it's not your problem anymore, and your work is done. But before recycling, you as I've mentioned, that there's still state of charge in the battery. It can be repurposed and reused. The problem is that it is quite difficult. Repurposing as a business case or reusing as a business case, it's quite difficult. It has its challenges, a lot of uncertainties such as safety risk, etc. So this clear vision, this clear focus about how is it possible, there's a lot of unanswered questions, and that's one of the gaps that I've been noticing. And that leads to government incentives, even for industries to undertake this circular economy strategies. What I've noticed is unless there's some sort of incentive, they won't do it, because as I've seen, or as I've read in my literature review, that recycling and repurposing for batteries even now is still considered expensive. So if there's not enough incentives, and I guess there was another question, is that what can government do? So I guess the answer to that would be, right now, as I mentioned earlier about Nissan undertaking these pilot studies. So more and more pilot studies, more and more funding from the government, incentives. And at the moment, I don't believe there's the Battery Stewardship Council has implemented a scheme, but I believe it's for smaller batteries. But those kind of schemes, those kind of maybe in the future mandatory schemes, any rebates for recyclers, that could be an incentive for more OEMs and recyclers to actually say, okay, let's sit around the table. This is what we can do with the batteries. This is where the batteries will end up, and not only stop at its second life, but also at its second life. So when it goes through it repurposing as an energy storage, will it go to the landfill or will it go back to the recycler? So we need this clear vision, this clear framework. And that's where collaboration is very important between the universities, between the government, between the industry. So I hope I answered that question.
Sorry, I
Yeah.
just add a little bit to
Yeah.
that, because it is true. If the government would provide an STC to something that is second use, it would actually be more attractive. Because right now, what they've gotten with solar panels is that you've got the rebate and you can get like the support to get new solar panels. But if you compare the prices for the new solar panels with the price that it will take to use a reuse solar panels, then the cost is not that attractive. And that's one of the biggest challenges that as far as being in the industry, not just solar panels, I guess that for batteries is the same.
Tasbirul, did you want to jump in from sort of a more industry perspective?
Yeah, so I just like to add with an example in Sweden. So in Sweden, if you do reuse-oriented businesses, so you will get the direct government incentive to operate those kind of businesses. So those kind of model and I guess could be effective. And another thing is that instead of giving like one-off payment in term, I mean, under the name of incentive, will not be a sustainable solution in this matter. So we need to create a system. For example, in Switzerland, we have a PRO, Producer Responsibility Organization, where this entity is making responsible like the importers, manufacturers, and all the supply chain partners together, and they are financing those systems to run the whole operation. So regardless of the lifespan of a a battery system or solar PV, at the end of life, if it requires to be recycled, so the whole partners who donated or put the money inside that organization carry on the entire operational aspects of those recycling. And one other and another important fact that I always consider, that in terms of reusing kind of resource loop, we need to combine these two streams together as a one single pack. So solar PV and battery could be integrated as one single product. And in that case, we of course require the certification system testing, because if we want to decommission the solar panels, it requires some certain operation and later on the certification process that Alex and Alston mentioned. So we need some intermediate processes to make it economically viable, and at the same time to make it safer for the consumer, to make it as a whole system and use it. Let's say we want to use in a solar in a social housing context, or in a context where currently there is not much penetration is there. So and also in the business model perspective, we need to do the business experimentation. So it requires some space where startups and spin-offs could get some incentive from the government to test those kind of pilots. So there are a whole lot of supply chain partners related cooperation and new kind of testing regime needs to be required if we want to focus on reusing the things.
Fantastic. Thank you, Tess. I'm going to ask one final question from Akvan, which I think sort of sums up the complexities and sort of barriers that we see at a system level. So Akvan asks, if EV batteries last only about 10 years, and given the environmental impacts of the production of those batteries, as well as disposal, is it more environmentally friendly for consumers to keep using their petrol vehicles for longer rather than discarding them and switching to EVs?
That's a good question, Akvan. Thank you. I think the whole goal why we are switching from ICE to EVs is to reduce the carbon footprint and overall to meet the end goal we set in the Paris Agreement, that is a rise in temperature to less than 1.5 degrees Celsius. That being said, I do believe that right now we may not see the benefits of maybe the pilot studies and so on and so forth, what's happening. But as we have seen that we need batteries, because batteries, complement solar farms, wind energy, hydro energy, etc. So the whole idea of why we need batteries, why the electric vehicles actually supporting the grid, feeding back to the grid, not only to run your vehicle, it's creates a less burden on the grid. So in terms of what EVs can do versus, comparing the benefits to ICE engines, I believe EVs, I would say, is the answer.
Okay, fantastic. So I think a rousing call for sustainable materials and closed loop material flows. But as we've seen in this session, there's a lot of different sort of intervention points that we need to be working on, lots of different changes, whether it's to the way that we utilize materials, business models, closing some of those loops, etc. So it's 1:30, so we might leave it there. So thank you for all of your fantastic questions. A huge thank you to our panelists, so those in the room and also those online, for your time, and congratulations on your fantastic research. Thank you to the audience for joining, those in person and also those online for joining us from your respective homes or workplaces. I'll double check with our panelists, but I'm sure we'll be able to share both slides and contact details with all of the registrants after the session. So you should be able to follow up with any specific questions or contacts after that. So thank you, everybody, and have a fantastic afternoon.